Like the way we discussed about vectors in horizontal projectile motion, we must also do so for this projectile motion. So let me quickly show you the simulation again. So you can see the simulation here. So what I'm going to do is I'm going to get the initial conditions ready. And you can see I'm clicking on velocity vectors here. I'm actually trying to show how the velocity vector would look like at time t is equal to 0. But it's very challenging. Let me try. Yes, see that's the best I can do. So you can clearly see that the length of the arrow is so much. It's big, and it's also making an angle with respect to the x-axis. So this is what is giving us the uh, velocity at time t is equal to 0. In this case, it's not exactly at time t is equal to 0, but close to 0. So you can clearly see there is some length and there is an angle associated with it. So given this vector, will I be able to find out the horizontal velocity and the vertical velocity? Please remember this. This is the resultant velocity which we're talking of. The green arrow which you're seeing on your screen right now is the resultant velocity. That's the velocity with which the ball is actually traveling. But for the better understanding, we are going to look at this motion as horizontal motion and vertical motion separately, right? So for that sake, will we be able to divide this vector into horizontal and vertical velocities is the question. So let's see how we can do that now. So let me go back to my iPad screen. Okay, so let me quickly draw the axis there. So you have x-axis here, correct? You have your y-axis here, correct? And if you remember, the speed was initial velocity was 18 meter per second. It was there in the left hand corner, and the angle which I selected was 45 degree. So which means let's say the length is this much, and this is 45 degree. Hope you realize the fact that this is not drawn to scale. Please remember, I'm not drawing this to scale. It's 45 degree, right? Now, as I just told you, is there a way to split this into two directions, basically across x direction and y direction, so that I get the horizontal velocity and the vertical velocity, in this case at time t is equal to 0. So if let's see what we can do now. So what I can do is I can actually uh, complete this rectangle here, correct? So if I do that, you would realize the fact that I have a right angle triangle here. This region is a right angle triangle, correct? That's a right angle triangle. Now all I need is the length of this length. That's all I need if you think about it, because this is V equals 18 meter per second to be precise, right? And that's acting at an angle with respect to the x-axis, and then my goal is to split, or rather find what is the velocity across x-axis and what is the velocity across y-axis. If you think about it, we are just doing the opposite of what we did in the horizontal projectile motion. So how do I find Vx? So if you can see, we have a right angle triangle here, right? Correct? And we know the hypotenuse to be so much, 18 meter per second, correct? And we want the adjacent side, which means it's basically cos theta we are talking of. So cos theta becomes adjacent, which is Vx. Okay, I'll write it as adjacent by hypotenuse. So what is adjacent? That's what I call it as Vx. And what is hypotenuse? In general, it can be called as V, resultant velocity, correct? I'm just going with the general term so that we can generalize it. So which means Vx then becomes V cos theta. In this case, very specifically, Vx is at time t is equal to 0. Don't forget that. We're talking of at time t is equal to 0. 18 cos 45 degree. That's the horizontal velocity of the cannonball at time t is equal to 0. Right? Now, how about the vertical velocity? Now, vertical velocity, if you think of that, again, we are interested in the length of which line? We are basically interested in the length of this line, right? Yes, no, that becomes Vy. And if you think about it, the length of this line will be the same as the length of this line because they are parallel sides of a rectangle. So again, going by the same right angle triangle which we took, which is this one, we're going to use the same right angle triangle, right? If I go with the same right angle triangle, I need the opposite side now, while I have the hypotenuse, right? So which means you know for a fact that we are talking of sine theta now. So sine theta equals opposite by hypotenuse. What is opposite side? That's Vy, velocity in the vertical direction. Yeah, divided by V, the resultant velocity. So which means V then becomes Vy sine theta. Right? In this case, specifically at time t is equal to 0, it's nothing but 18 sine 45 degree. This process, this process is what we call as resolution of vectors. What does the word resolution means? It's basically we are breaking down the vector into two perpendicular components. That's what this means. Yeah, you can clearly see I have broken down the velocity into two perpendicular components, one across x-axis and one across y-axis. And this is a very important concept. And please remember, this holds true for all vectors. Need not be for velocity only. We have done it for velocity, but it can be done for all the vectors. I'll continue on this in the next video.